Chapter 11 of Arizona Sketches by Joseph A. Munk. This LibriVox recording is in the public domain. Reading by Bologna Times. The Meteorite Mountain. 10 miles southeast of Canyon Diablo Station on the Santa Fe Pacific Railroad stands the Meteorite Mountain of Arizona on a wide open plain of the Colorado Plateau. It is 200 feet high and, as seen at a distance, has the appearance of a low, flat mountain. Its top forms the rim of an immense, round, bowl-shaped hole in the ground that has almost perpendicular sides, is 1 mile wide and over 600 feet deep. The hole, originally, was evidently very much deeper than it is at the present time, but it has gradually become filled with debris to its present depth. The bottom of the hole has a floor of about 40 acres of level ground which merges into a talus. This formation is sometimes called the crater because of its shape, but there is no evidence of volcanic action. Locally, it is known as Coon Butte, which is a misnomer, but Meteorite Mountain is a name with a meaning. It is not known positively just how or when the mountain was formed, but the weight of evidence seems to favor the meteorite theory, which is that at some remote period of time a monster meteorite fell from the sky and buried itself in the earth. Mr. F. W. Volz, who has lived in the country 20 years and is an intelligent observer of natural phenomena, has made a careful study of the mountain, and it is his opinion that such an event actually occurred and that a falling star made the mountain. When the descending meteorite, with its great weight and terrific momentum, hit the earth, something had to happen. It buried itself deep beneath the surface and caused the earth to heave up on all sides. The effect produced is aptly illustrated on a small scale by throwing a rock into thick mud. The impact of the meteorite upon the earth not only caused an upheaval of the surface, but it also crushed and displaced the rocks beneath. As the stellar body penetrated deep into the earth, its force became more concentrated and either compressed the rocks into a denser mass or ground them to powder. The plain on which the mountain stands is covered by a layer of red sandstone of variable thickness, as it is much worn in places by weather erosion. Below the top covering of red sandstone lie 300 feet of limestone, and beneath the limestone 500 feet more of white sandstone. This arrangement of the rocks is plainly seen in the walls of Canyon Diablo. The displaced strata of rocks in the hole are tilted and stand outwards, and great boulders of red sandstone and limestone lie scattered all about. If the hole had been made by an explosion from below, large pieces of rock from each one of the different rock strata would have been thrown out. But while, as just stated, there are plenty of huge blocks of red sandstone and limestone, there are no large pieces of white sandstone. After the superficial layers of rock had been broken up and expelled en masse, the deeper rock of white sandstone, being more confined, could not reach the surface in the shape of boulders, but had first to be broken up and ground to powder before it could escape. Then the white sandstones in the form of fine sand was blown skywards by the collision, and afterwards settled down upon the mountain. The mountain is covered with this white sand, which could only have come out of the big hole, as there is no other white sand or sandstone found anywhere else upon the entire plain. In the vicinity of the mountain, about 10 tons of meteorites have been found, varying in size from the fraction of an ounce to 1,000 pounds or more. Most of the meteorites were found by Mr. Volz, who searched diligently every foot of ground for miles around. The smaller pieces were picked up on or near the rim, and they increased in size in proportion as they were distant from the mountain until, on a circle 8 miles out, the largest piece was found. Meteorites were found upon all sides of the mountain, but they seemed to be thickest on the east side. The writer first visited the mountain in the summer of 1901, and it was the greatest surprise of his 6 weeks' trip sightseeing in northern Arizona, where are found many natural wonders. He was fortunate enough to find a 3-pound meteorite within 5 minutes after arriving on the rim, which Mr. Volz said was the first specimen found by anyone in over 4 years. Professor G.K. Gilbert of the United States Geological Survey visited the mountain several years ago to investigate the phenomenon and, if possible, to determine its origin by scientific test. He gave the results of his researches in a very able and comprehensive address delivered before the Geological Society of Washington, D.C. The existing conditions did not seem to fit his theories, and he concluded his work without arriving at any definite conclusion. After disposing of several hypotheses as being incompetent to prove the origin of the mountain, he decided to try the magnetic test. He assumed that if such a meteorite was buried there, the large mass of metallic iron must indicate its presence by magnetic attraction. By means of the latest scientific apparatus, he conducted an elaborate magnetic experiment, which gave only negative results. He discussed at length the various hypotheses which might explain the origin of the crater, and concluded his notable address as follows. Quote, "Still another contribution to the subject, while it does not increase the number of hypotheses, is nevertheless important in that it tends to diminish the weight of the magnetic evidence and thus to reopen the question, which Mr. Baker and I supposed we had settled. Our fellow member, Mr. Edwin E. Howell, through whose hands much of the meteoric iron has passed, points out that each of the iron masses, great and small, is in itself a complete individual. They have none of the characters that would be found if they had been broken one from another, and yet, as they are all of one type and all reach the earth within a small district, it must be supposed that they were originally connected in some way." Reasoning by analogy from the characters of other meteoric bodies, he infers that the irons were all included in a large mass of some different material, either crystalline rock, such as constitutes the class of meteorites called stony, or else a compound of iron and sulfur, similar to certain nodules discovered inside the iron masses when sawn in two. Neither of these materials is so enduring as iron, and the fact that they are not now found on the plain does not prove their original absence. Moreover, the plain is strewn in the vicinity of the crater with bits of limonite, a mineral frequently produced by the action of air and water on iron sulfides, and this material is much more abundant than the iron. If it be true that the iron masses were thus embedded like plums in an astral pudding, the hypothetic buried star might have great size and yet only small power to attract the magnetic needle. Mr. Howell also proposes a qualification of the test by volumes, suggesting that some of the rocks beneath the buried star might have been condensed by the shock so as to occupy less space. These considerations are eminently pertinent to the study of the crater and will find appropriate place in any comprehensive discussion of its origin. But the fact which is peculiarly worthy of note at the present time is their ability to unsettle a conclusion that was beginning to feel itself secure. This illustrates the tentative nature not only of the hypotheses of science, but of what science calls its results. The method of hypotheses, and that method is the method of science, founds its explanations of nature wholly on observed facts, and its results are ever subject to the limitations imposed by imperfect observation. However grand, however widely accepted, however useful its conclusions, none is so sure that it cannot be called into question by a newly discovered fact. In the domain of the world's knowledge there is no infallibility." Unquote. After Professor Gilbert had finished his experiments, Mr. Volz tried some of his own along the same line. He found upon trial that the meteorites in his possession were non-magnetic, or practically so. If these, being pieces of the larger meteorite which was buried in the hole, were non-magnetic, all of it must be non-magnetic, which would account for the failure of the needle to act or manifest any magnetic attraction in the greater test. Mr. Volz also made another interesting discovery in this same connection. All over the meteorite zone are scattered about small pieces of iron, which he calls iron shale. It is analogous to the true meteorite, but is burnt or dead. He regards these bits of iron as dead sparks from a celestial forge, which fell from the meteorite as it blazed through the heavens. In experimenting with the stuff, he found that it was not only highly magnetic, but also possessed polarity in a marked degree, and was entirely different from the true meteorite. Here was a curiosity, indeed, a small, insignificant, and unattractive stone possessed of strong magnetic polarity, a property of electricity that is as mysterious and incomprehensible as is electricity itself. Another peculiarity of Cañon Diablo meteorite is that it contains diamonds. When the meteorite was first discovered by a Mexican sheep herder, he supposed that he had found a large piece of silver because of its great weight and luster, but he was soon informed of his mistake. Not long afterwards, a white prospector who heard of the discovery undertook to use it to his own advantage by claiming that he had found a mine of pure iron, which he offered for sale. In an attempt to dispose of the property, samples of the ore were sent east for investigation. Some of the stone fell into the hands of Dr. Foote, who pronounced it to be a meteorite and of celestial origin. Sir William Crookes, in discussing the theory of the meteoric origin of diamonds, says, "The most striking confirmation of the meteoric theory comes from Arizona. Here, on a broad open plain, over an area about 5 miles in diameter, were scattered from 1 to 2,000 masses of metallic iron, the fragments varying in weight from half a ton to a fraction of an ounce. There is little doubt that these masses form part of a meteorite shower, although no record exists as to when the fall took place. Curiously enough, near the center, where most of the meteoritics have been found, it is a crater with raised edges 3/4 of a mile in diameter and about 600 feet deep, bearing exactly the appearance which would be produced had a mighty mass of iron or falling star struck the ground, scattering in all directions, and buried itself deep under the surface. Altogether, 10 tons of this iron have been collected, and specimens of Cañon Diablo meteorite are in most collectors' cabinets. An ardent mineralogist, the late Dr. Foote, in cutting a section of this meteorite, found the tools were injured by something vastly harder than metallic iron, and an emery wheel used in grinding the iron had been ruined. He examined the specimen chemically, and soon after announced to the scientific world that the Cañon Diablo meteorite contained black and transparent diamonds. This startling discovery was afterwards verified by Professors Friedel and Moissan, who found that the Cañon Diablo meteorite contained the 3 varieties of carbon, diamond, transparent and black, graphite, and amorphous carbon. Since this revelation, the search for diamonds in meteorites has occupied the attention of chemists all over the world. Here, then, we have absolute proof of the truth of the meteoric theory. Under atmospheric influences, the iron would rapidly oxidize and rust away, coloring the adjacent soil with red oxide of iron. The meteoric diamonds would be unaffected and left on the surface to be found by explorers when oxidation had removed the last proof of their celestial origin. That there are still lumps of iron left in Arizona is merely due to the extreme dryness of the climate and the comparatively short time that the iron has been on our planet. We are here witnesses to the course of an event which may have happened in geologic times anywhere on the earth's surface. About a year ago, several mineral claims were located in the crater by a company of scientific and moneyed men. The required assessment work was done and a patent for the land obtained from the government. The object of the enterprise is for a double purpose. If possible, to solve the mystery of the mountain, and if successful in finding the hypothetic buried star, to excavate and appropriate it for its valuable iron. A shaft has been sunk 195 feet deep, where a strong flow of water was encountered, and a bed of white sand, which temporarily stopped the work. A gasoline engine and drill were procured and put in operation, and the drill was driven down 40 feet further when it stuck fast in white quicksand. It is the intention of the company to continue the work and carry it on to a successful finish. Nothing of value was found in the hole dug, but some of the workmen, in their leisure hours, found on the surface 2 large meteorites weighing 100 and 150 pounds respectively, besides a number of smaller fragments. The Meteorite Mountain is in a class by itself, and is, in a way, as great a curiosity as is the Grand Canyon. It is little known and has not received the attention that it deserves. It is, indeed, marvelous, and only needs to be seen to be appreciated. End of Chapter 11.